Hi everybody, this is Dr. Nigro with a Chem calculation screencast. This screencast is going to focus on skill building when naming and writing formulas for simple organic compounds. I want to be very clear, it's simple, all right? Organic compound naming is complicated. You've got substitutions, you've got chain links, you've got functional groups, and we are not covering that here. So if you're, let's say, looking at this video down the road and you're in organic chem in college, you need to go find a more robust video for that. This will give you some basics, but it is by no means comprehensive. Okay, so let's start by talking a little bit about what an organic compound is. All right, these compounds contain carbon backbones with hydrogens attached to those carbons, and then sometimes other elements such as oxygen, nitrogen, you see sulfur. All right, and there can be others. You can have specialized organic compounds, but most often you're going to have some sort of carbon backbone, which is a several carbons in a row. All right, and those carbons are going to have hydrogens attached to fill their four bonding sites, their tetrahedral shape, or you can have other elements attached, such as oxygen, nitrogen, and sulfur. All right, but the key is it's primarily going to be carbons and hydrogens with some other elements mixed in. All right, these molecules, classified is not quite the right way, but when you're naming or writing formulas, let me try that again. Actually, you know what? Let's do this. It's right here. All right. You need to know a couple pieces of information. You need to know the carbon chain length. All right. And for our purposes, you need to ID any functional groups. All right, and a functional group is what lets us divide the molecules into specific types of organic molecules. All right, and what it does for us is it sets the ending of the name. All right, and that's going to be our way to distinguish between different types of organic molecules, the ending of their name. All right, so let's lay out some general rules. All right, and again, these are very general. All right, if you're taking organic chem, go find a more comprehensive video. All right, the first thing you want to do is ID the longest continuous carbon chain. All right, once you do that, the number of carbon atoms determines the prefix in the name. All right, so similar with our covalent molecules where we use prefixes to indicate the number of each atom type, organic naming does the same thing, but that prefix is specific to the number of carbons within the main chain. Okay, again, the number of carbons in that main chain. Okay, so once we've done that, then we need to ID any functional groups. All right, and that's going to tell the suffix how that name is going to end. Okay, and then once we have that, we're going to combo that prefix and that suffix. All right, now that sounds pretty simple, but I guarantee, just trust me, it's not as easy as it seems. All right, now we are going to focus on three different groups of organic molecules. All right, so the functional groups that we are interested in, we're going to start by looking at a group called the alkanes. See that anes ending? All right, so this is all whoops, single bonds, and for our purposes, all carbons and hydrogens. All right, there are alkanes that can be what's called substituted, all right, but we are not going to be looking at those. We're going to stick with the simplest version. All right, so the suffix here is going to be, whoops, ane. All right, so if you have a name and it ends in ane, then you know it's an alkane. Okay. We are also going to look at a group called the alcohols. All right. And in organic chemistry, they use the R to represent the main chain, the main carbon chain, and then the functional group is listed. So whenever we have a long or a carbon chain of any length and it ends with an OH group, that's considered an alcohol. So R would be the carbon chain and the OH is the functional group. All right. So here, the suffix is going to be OL. So ethanol, propanol, hexanol. All right, so if you see that OL ending in your name, you know you have an alcohol. All right, and then finally, carboxylic acids. All right, and for these, you would have your carbon chain, and then your functional group is COOH. All right, now, the prefix that you're going to use is going to include all of the carbons in the R group and that carbon in that COOH group. Don't forget that guy. All right. And this piece looks like this, carbon, double bond oxygen, OH group out here. All right. That's what that functional group looks like in terms of structure. All right. Now our suffix, whoops, it's terrible. Try that again. For these is going to be oic acid. Okay, so again, we've got our alkanes that end in ane, our alcohols that end in -ol, and our carboxylic acids that end in oic acid. All right, so you might ask, well, then what goes in front of that? All right, so that's where the prefixes come in. And again, these are the carbon chain prefixes. So we'll again look at 1 through 10. And I know you're saying, but Dr. Nigro, we learned these for the covalent molecules. Well, unfortunately, they are not the same. All right, so if you have a compound, an organic compound that has 1 carbon in it, it begins with meth. If you have 2 carbons, all right, then it's eth. 3 carbons is prop. 4 carbons is bute. 5 carbons is pent. 6 carbons is hex. 7 carbons, whoops, what are you doing? Oh, stop it. 7 carbons is hept. 8 carbons is oct. 9 carbons is non. And 10 carbons is dex. So some of them are the same, but these 4, you got to remember these. All right, those are different from our covalent prefixes. All right, and the way it's going to work is you're going to treat that initial carbon chain as a prefix ane, and then you're going to change that E at the end to all or oic acid if you need it. All right, so let's try a couple of these. All right, so we've been given heptane. So that ane ending tells me that this is an alkane. And that hept tells me I must have 7 carbons in it. All right, now this is where things get a little tricky. All right, we haven't done bonding yet. We haven't done structure drawing yet. So it can be a little hard visually to think about how many hydrogens and carbons you need. The thing to keep in mind is carbons, they like to participate in 4 bonds. All right, now whether they're single bonds, double bonds, triple bonds, carbon does not care. It just wants 4 bonds. It does not like to have lone pairs. It wants 4 bonds. So if you were to draw out a structure of heptane, you would draw 7 carbons, 6, 7, and then you would have to fill in these 3 bonds would be our hydrogens. These 2 would be our hydrogens. These 2 would be hydrogens. You can see where I'm going with this. And then we would end with 3 hydrogens on this end one. And if you look, each carbon in this chain has 4 bonds. All right, that is what an alkane looks like. Now, in 3 dimensions, it looks a little bit different. It's a little up and down because of the bond angles. But again, carbon likes to have those 4 bonds. But let's say, you're in your first month of AP chemistry and you didn't know that yet. Is there an easier way? Well, there is. All right. To do the formula from the name, you're going to write carbon, and this N is going to be whatever the prefix is telling you it should be. And then the number of hydrogens you need is 2 times that value plus 2 extras. All right, because if you look, there are 2 hydrogens on each of my middle ones, and then 2 on the 2 N ones plus an extra on each end. So that's where this formula comes from. This formula only works for your alkanes. All right, so do not try to use it for alcohols or carboxylic acids. We'll talk about those in a minute. All right, so for this particular situation, I would have C7, and then H, 2 times 7 is 14, plus 2 is 16. And if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 hydrogens were showing in my structure. So that is the correct way to write the formula for heptane. Okay? All right, now we're going to move on to our next one. Here we have butanoic acid. So this is a carboxylic acid. All right, and I know from the but part that there must be 4 carbons in the main chain. All right, so again, I'm going to draw it just to make sure that you guys understand what's happening. So we're going to have 1, 2, 3, 4, and this 4th one is the functional group. So there's the COOH. All right, and then I'm going to check by filling in hydrogens to give each of my other carbons 4 bonds. All right, so I have C, and this is where it gets a little tricky. 3, H, 1, 2, 3, 4, 5, 6, 7, and then the functional group. All right, so C3H7COOH. All right, so 4 carbons total, and then our hydrogens. So what if I wanted a quick way to do that? All right, the way it's going to work is you're going to say CN-1, H, 2N+1, and then COOH. And that should get you the right formula each time. All right. Now, the reason that first C is -1 is because we leave that carbon in the functional group, but it is part of the main chain, so it gets counted in that prefix. Okay. So C3H7COOH. All right. Next, we have propanol. That OL tells me alcohol. And that prop piece tells me 3 carbons. All right. So I'm going to have 1, 2, 3, and then my functional group, OH. Then I'm going to put hydrogens in to give everybody the 4 bonds they like to have. And by they, I mean carbon. And you can see that this OH group is acting as the 4th bond for my end carbon. All right. So if I count everything up, I have C3, and then I have H, 1, 2, 3, 4, 5, 6, 7, OH. And that will be the formula for propanol. All right. Now, if I want a simpler way to remember, Cn for the number of carbons, and then H, 2N, and instead of being +2 like the alkanes, it's only +1 because my functional group is serving as one of the hydrogens that would have happened down in my alkane. Okay, now please note with all of these, this AN bit. All right, so all of the names are going to include AN. It's just if it ends in E, it's an alkane. If it ends in oic acid, it's a carboxylic acid. If it's in OL, it's an alcohol. All right, so let's look at our formulas. Whoops. All right, so we've got OH, so this is an alcohol. All right, I've got 5 of them, so that's going to be pent for my prefix. All right, so it's going to be pentanol. All right, so this is going to be the name for this particular alcohol. All right, next, only carbons and hydrogens, so this is an alkane. I've got 9 hydrogens, so that's known, so nonane. It's going to be the name for that alkane. And then over here we have this group. All right, so this is my carboxylic acid group. There are 2 carbons, so that's N, and then we ended in oic acid. Now, if you're paying attention, you might note that that actually is also called acetic acid. And we're going to find that particularly with the carboxylic acids, for the methanoic acid and the ethanoic acid, there are what are called common names. And for ethanoic acid, we most commonly refer to it as acetic acid. All right. For methanoic acid, we most often call it formic acid. All right. But we're not going to get into the nitty gritty of that today. All right. So again, if it's mostly carbons and hydrogens with maybe an oxygen, well, you probably won't see any nitrogens for our purposes or sulfurs, but they could be there. All right. Then we've got some sort of organic molecule. All right. You need to ID the longest continuous carbon chain, and that's going to set your prefix. Our prefixes are meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. All right. We're going to then look to see if there are any functional groups in that formula. If it's just carbons and hydrogens, it's an alkane. If there's an OH group, it's an alcohol. And if there's a COOH group, that would be a carboxylic acid. All right. And then that that functional group determines the suffix of your name. Okay. If you're going from the name to the formula, you need to be careful. All right. This handy little formula will help with the alkanes. This will help with your carboxylic acids, and this will help. Oh, whoops, I left something off of there though. It should say OH at the end. All right, this will help with your alcohols. Okay. All right. So again, just like with any other naming convention, practice. You got to practice. All right. Let me know if you have any questions.